Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
I am so excited about this one. I am so excited. So I remember.
I can expect a bit of interjecting, yes?
Oh, I can expect a lot of excited interjecting. Yeah, we'll see. But Now, I'll set some context from my point of view first of all, because that's how excited I am. I had been following with you, both of you, over time, from when I became aware of it, the construction of the James Webb Space Telescope, which is what this segment's going to be about. I remember on Christmas night, all right? So, this is not Christmas Eve, but Christmas night. So, because the launch had been delayed, I remember watching the launch at close to midnight, I think it was. It was a ULA rocket launching the James Webb Telescope. And I just remember being in awe already. And at this point, I hadn't known what kind of images we would see, knowing that they were probably going to be better than Hubble in some kinds of ways. Yeah. Hadn't seen. But I was already in awe watching this mission and then seeing so you got to see the telescope drift away, fly away from the second stage of the rocket there. And just thinking, this thing is going to go. And you and I, Lino, did a segment on this earlier this year. This thing is going to go a million miles away from Earth and be in that orbit, of the Earth and the Sun. And at some point, it's going to continue unfolding itself and opening up and aligning its mirrors, and then the fun's going to begin. And the fun has begun.
Totally fun.
So, Caroline,
totally fun.
Tell us about the fun that has come from, as more than fun, but tell us about the fun, the joy that the James Webb Space Telescope has given us.
Is the
wonder.
best word. That's right. So yes, we have the first images from the James Webb Space Telescope. And of course, it's a project led by NASA, but European Space Agency and other agencies are involved. So like you mentioned, it was launched on December 25th from French Guiana, and on an Ariane 5 rocket. So the last time we spoke about it as well, in an earlier episode, it was still undergoing commissioning. So you spoke about its launch, and then we had a episode about what it was all about. Yes?
Sorry, I just realized that in my little introduction, I said a ULA rocket. You're right. Yeah, it was a European Space Agency. Sorry, I was correction there. Yeah.
That's okay.
Please continue.
Yeah. Thank you for raising your hand, by the way. Yeah.
Yes.
So we spoke about how it had launched and it had been in space for a while and had been undergoing its commissioning. So the mirrors were being aligned, and the instruments were cooling down because you have to get to a certain temperature for them to really work well. So I thought I'd just quickly recap what instruments are on board, because we will be mentioning them while we talk about the images. So there is a near-infrared camera, which is NIRCam, provided by the University of Arizona. A near-infrared spectrograph, NIRSpec, provided by a European Space Agency and has NASA components on it. A mid-infrared instrument, the MIRI, provided by European Consortium with ESA and the Jet Propulsion Laboratory from NASA, and a fine guidance sensor / near-infrared imager and slitless spectrograph provided by the Canadian Space Agency. So all of the images are being taken using instruments that observe infrared and mid-infrared light. The reasons for this are that the very old and distant objects emit in the infrared spectrum, so their light can be only observed by infrared astronomy, and colder objects and planets also tend to emit light most strongly in the infrared. It's also able to see through dust clouds in nebula and able to view even better the birth of stars and to be able to study the atmosphere of exoplanets orbiting other stars. So that's just a very quick prelude. Now, the first images were released on June the 12th, and they're the highest resolution pictures taken from space ever.
Ever.
Ever. And the images they come in as a raw form, and then they are color processed by putting filters through the images, and they layer the different colors of filter on. And not only does this make for amazingly gorgeous, beautiful pictures, but it actually highlights all the features that we haven't seen before. So Hubble was amazing. Okay, I used to adore the Hubble images.
Absolutely.
I was inspired to paint pictures from Hubble, but when we look at the same pictures compared to those taken by James Webb, it's like putting on a pair of amazing glasses, and you are able to see. It's like I'm seeing clearly, like you can pierce through the clouds and all of that. So I'm giving Lino the honor of going through the first image that was presented. Lino, would you like to tell us about this image?
This image, I must admit, guys, thank you, Caroline, for this. It's amazing. It's something you can always put on as a wallpaper and to remind everyone that this universe we're in is endless. It is amazing. So this James Webb Space Telescope, just to recap on everyone who's listening, that this telescope is the size of a tennis court. Is that correct, Lindsay? We're talking about?
Yep.
So this thing, it made to us, maybe it's big for us, but in the universe, it's a tiny little thing, and it looks like a honeycomb if you see pictures of it, and is able to take pictures like this. I'm just totally mind blown. from something that size to take pictures like that, it is just, totally amazing. So it's taken pictures of other galaxies, and I was talking to you guys about we're still exploring our galaxy. We're just a solar system, so we're still doing ours, and we're looking at another galaxy out there. 4.6 billion years ago, and the cluster is called you call it SMACS, or should I just go S?
SMACS. So it's a region, isn't it? Yeah,
it's a region.
Okay, it sounds horrible in a sense, but anyway, SMACS 0723. So but it's amazing, but knowing that they, I think we
tell us what you see. Tell us what you see.
It's just galaxies of bright light. I'm just too blown away to thinking that there are other galaxies out there and other planets out there that they're still going around. You know what I mean? It's unbelievable.
It makes you speechless. It makes you speechless when you think about it.
It does. I'm looking at it like one little galaxy, and I'm thinking, oh my gosh, like Caroline said, there's other planets within that other galaxy. And
other stars with planets. Imagine that.
Oh my goodness me! Look, I think we talked about this. I'm going to have to ask everyone. I'll probably blow the Discord and social media and everything, but there is 1 billion. What's it? Betting, whatever they call it. We are definitely not alone in this universe. Come on. There's definitely something out there.
Makes you wonder.
Was it Jimmy Akin? You have to see this, and you have to comment about this.
I'm sure he will. I'm sure he will.
Probably.
Yeah, it's unbelievable.
Yeah. And he's done many episodes on the existence of aliens. Yeah, interesting, alien encounters and so on.
That's true. That is true. Yeah. It's just only the question is, have they visited us and all that stuff? But I don't want to get into that conversation. That's for Jimmy to do. Yeah. But it's unbelievable.
Yeah, what I thought was interesting about this image is that the SMACS region, if you were to look at the night sky, your entire field of view, it makes up one speck of sand of a size.
Exactly.
And in this image, what are we seeing? We're seeing hundreds of galaxies. And this is just in one little area. So if you think of our galaxy, right? So we've barely scratched going beyond the solar system with some probes that left decades and decades ago. And we'll probably come back as a giant space probe looking for the crater. That's Star Trek one, by the way. I'm just putting that out there. Yep. I'm looking at you, Voyager 6 or 7, whichever it was. Yep. But the thing is, within this Milky Way galaxy, we're talking about, correct me if I'm wrong, Caroline, but billions of stars, right? Would that be fair, or is it, or trillions?
Yeah.
What would be the accurate?
What is the number?
Yeah. All right. So we can't.
That's the question.
You're safe saying more than billions for sure, right? So,
Sure.
and those stars many of them have planets in orbit around them.
Yeah, that's the mind-blowing thing about
and
it.
This is our, and so this
and those
is
planets
our one,
have little moons.
yeah, and this is our one galaxy. And now, Lino, this image you were just describing to us is showing stacks of galaxies, and that's in the grain of a sand when you look at the size, when you look at the night sky. So just think about how small we are, people.
Oh my goodness,
how amazingly
me.
vast this universe is. You know, when I saw this image and the others, the first thing that came to my mind was, and God saw that it was good. That was what I thought of straight away.
Yep.
Yep. And that's what I posted on Discord. I was very inspired, so I put it there in the Let's Science channel. But the other thing as well is that what got me right is, Lino, you mentioned that those the lights from those galaxies in that particular region were 4.6 billion light years away. That's how long it's taken for that light to reach us. But there were galaxies behind that cluster. And I think they were saying that some of them could be 13.1 billion years old, that light. And our universe is about, I think it's 13.7 billion years approximately. So we're looking at the, like as close to the beginning right now as of light that we can capture at the beginning of our universe.
And I always think too, like, okay, that's what they looked like then. What do they look like now?
Yeah.
Oh, wow. Yeah.
It's all mind-blowing.
And look, it's and from the article, look, the researchers are still getting the data from James Webb.
Oh, this is all fresh. Yes. And they've got so much planned. Yeah.
You can imagine the researchers, they'll be salivating. They'll be looking at, oh my gosh, look at this.
Oh, for sure.
And you know, the difference too between Hubble and James Webb is that the James Webb is able to take images in a matter of hours. Like
yes, that's right.
It can take hours just to get an image, but Hubble used to take weeks or months. I think it was weeks to like kind of take an image.
Yep.
It would have to just like look at something for a really long time to get the information.
Yep.
James Webb is able to just look at something for hours and then gets the information. And imagine how fast now we're going to be getting images. So
I think we can safely say that long after James Webb has died and decommissioned or whatever, they will still be unpacking the science from James Webb.
There still will be.
Because it's not just a giant camera, it's also taking measurements. Like you said, Caroline, it was measuring the atmospheres of exoplanets and all that. Yeah,
it's got the spectrograph, which can read the chemical composition of whatever it points to,
My
really.
goodness,
So,
Oh, wow.
Yeah.
And then they can figure out temperature and atmosphere and pressure and all that. But hey, we can keep talking about all this. Should we go on to the next image?
We could go on for hours about this one. Go for it, Caroline.
Let's go for the next one. And I suggest that you look these up while we're talking about it because it makes more sense.
Yes, it does.
So I'm going to talk about next the Karina Nebula.
Oh, this was
this is one of the images that really, when you compared the Hubble to the James Webb Space Telescope version, is like, wow. So this is the edge of a star-forming region called NGC 3324, located about 7,600 light years away. And it's just so much detail. What can we see? So we can see, like, it's basically big gas cloud. It's like mountains and valleys and pillars of gas, which the peaks of the mountains themselves are about 7 light years high. So that's, just that. Can you imagine that? So the gas is being carried around by ultraviolet radiation and stellar winds of hot young stars. It shows hot ionized gas streaming out of the nebula. It's a really great picture of like a stellar nursery and provides great information on how stars are formed. So from the NASA site, it says these observations of NGC 3324 will shed the light on the process of star formation. Star birth propagates over time, triggered by the expansion of the eroding cavity. As the bright ionized rim moves into the nebula, it slowly pushes into the gas and dust. If the rim encounters any unstable material, the increased pressure will trigger the material to collapse and form new stars.
Amazing.
Conversely, this type of disturbance may also prevent star formation, and as the star-making material is eroded away. This is a very delicate balance between sparking star formation and stopping it. Webb will address some of the great open questions of modern astrophysics. What determines the number of stars that form in a certain region? Why do stars form with a certain mass? So just from this image, already a few questions are being posed, and we can learn so much just from this picture.
Wow.
Yes, amazing.
Yeah, it really
It's just, I love this. I mean, for me, something I love to look at are pictures of nebula, and it's been my favorite thing from Hubble. And just imagining the gases, being smashed together and making a star. It's just an amazing thing to think about, Yeah. So I'm blown away.
I'll share this in the show notes, but I just remembered, I just looked it up now as well, and I'll put it in our chat if you want to have a look at it. But on Facebook, someone created a 360 composite of this image. So you could look around in 3D and look up and down and everything. So there's a Facebook post. I'll put it in our show notes too.
Super
but
amazing.
It's a beautiful way to explore that. But that was the last image they showed, wasn't it? It was the fifth one. And it was 5:30 in the morning. No, sorry, it was 1:30 in the morning Australia time when I watched.
Yeah, it was the last one. Yeah.
And I was in bed. Isabel was fast asleep, and I couldn't sleep because I was just blown away by this. And I yelled out loud when I saw it because I was just stunned. And then Isabel said, "Go back to sleep." But and I was like, "You've got to look at this. You've got to look at this." But it was the one of the scientists or astronomers who was looking at the image when she introduced it said, "There are formations here. We don't even know what they are."
Yeah, she's like, "What is that?"
We didn't know what they are. And there are stars in this image. We've taken an image of this region before, but there are stars in this image we've never seen before.
Exactly.
So there are new stars, even more. It's just
yeah. So if you're able to look up the Hubble version of this one, you'll see that the clouds are kind of just clouded over, really, and you might see pink dots kind of dimly inside.
Yeah.
But this one really exposes all the stars, and like you said, things that we haven't seen before. Like
this is next
really
level
brings
something
out,
else.
It's looking inside the cloud, not just like on the outside. Yeah. No, it's like, and I heard somebody, there was a question answer, and they were saying, imagine like x-raying something. It's not using x-rays, but imagine like x-raying your body, and you can see your outside, but then you do an x-ray and you suddenly see the inside of it. So it's equivalent to that, really.
Wow.
Yes,
awesome.
that image was. I'm glad they definitely saved the best for last. They
did.
Yes.
But the others are just as amazing.
Absolutely,
So yes, let me go on to the next one. So I'm going to talk about Stefan's Quintet next.
Yep.
Okay, this is also mind blowing, and I'll tell you why. So it's a picture of 5 galaxies in the foreground, and now if you look in the background, there's also many, many stars and many galaxies. James Webb just can't help it. Okay, it takes
showing off. He's showing off.
Everything that's there. It's like, I look at this. Okay, you want to look at this, but I'm also going to include all of this.
And here's a couple of other galaxies. Here you go.
Yeah. So the image was actually constructed using 1,000 separate image files. It contains 150 million pixels, and if you were to get the size of the image, it's about 1/5 the moon's diameter. It's not a picture you can just like in raw version put on the wall. Okay? Like you can put it on the moon's wall maybe.
Ridiculous.
Yes, it's amazing. I feel like actually I want to print it out and put it on my wall now. I've said that.
I'm looking at it right now. It's just
it's gorgeous. So we see 5 galaxies, we see clusters of stars. They're all in close interaction, these galaxies. 2 of the galaxies, which I saw, the first thing that popped out to me, because I just think it's an amazing thing to think about, is that 2 of the galaxies are in a process of merging together.
Yes, wow.
And to me, just the idea that our galaxy could possibly merge with another one, it's like, I don't know how that would go down. But anyway.
What are we, 5 billion years away from merging with the Andromeda galaxy, I think.
And luckily for us, we have a short lifespan, but I mean, goodness gracious.
You know, if humanity doesn't work out how to travel to other places by 5 billion years from now, I reckon that is the biggest example of procrastination ever.
I know, exactly.
The next generation will do it.
Cool.
Yeah, next generation will do that one. Yeah.
Oh my gosh. Yeah, let them do it. So from the website, together the 5 galaxies of Stefan's Quintet are also known as the Hickson Compact Group. So 92. So you've got 8 HCG 92. Although called a quintet, only 4 of the galaxies are truly close together and caught up in a cosmic dance. So they're really close together, in space terms. The 5th and leftmost galaxy, called NGC 7320, is well in the foreground compared with the other 4. NGC 7320 resides 40 million light years from Earth, while the other 4 galaxies are about 290 million light years away.
Goodness
so
me.
those are the ones that are actually close to each other.
Yes, right.
Okay.
Yeah. They look almost like they're sharing material there.
They do.
Yeah.
They do, don't they?
Yeah.
This is still fairly close in cosmic terms compared with the most distant galaxies billions of light years away. Studying such relatively nearby galaxies like this helps scientists better understand structures seen in more distant universe. And it says the proximity provides astronomers a ringside seat for witnessing the merging and interactions between galaxies that are so crucial to all of galaxy evolution. Yeah, so how cool is that?
Yeah.
And then there's this, which I wanted to read. It says tight groups like this may have been more common in the early universe when their superheated, infalling material may have fueled the very energetic black holes called quasars. Even today, the topmost galaxy in the group harbors an active galactic nucleus, a supermassive black hole, 24 million times the mass of the sun, and it's still actively pulling material and puts out light equivalent to 40 billion suns. So, you look at the image and then you think about what's going on, and a lot is going on, and it's all mind-blowing stuff.
My brain can't do it. Yeah, can't process it.
It's like, and that's why they have specific astronomers and scientists who concentrate on one thing, because you just can't possibly.
There's too many things. Yeah. Even if you dedicate every person in the human race to studying one thing, you just won't be able to study everything.
You can't. It's too much.
Yeah.
Anyway, wow. Shall we go to the next one?
Yes.
Can you take it?
Not really,
All
but
right.
Let's go.
Let's do some more. So this one is such a pretty photo. I love it. So it's called the Southern Ring Nebula, and it is of a dying star, star in the process of leaving the world. However, what it shows is a beautiful but dimly lit star in the center of a large ring of gas and dust. It's named NGC 3132 and is about 2,500 light years away. So the ring of gas and dust is actually made of layers or shells. Each shell of gas was created as the gas was ejected by the star, and the gas and dust is measured, and then they can find out, learn about the history of the star. Of its life, and as it dies, they just learn more about how the star ends its life. The star is also cool because it's a part of a system of 2 stars. So it's a binary star system, and the NeoCam imaged the layers of the light in this image, and Miri highlighted the dust around the stars, so the 2 different cameras can get different information working together. The brighter star is actually in an early stage of its evolution, so it's younger than the other star. And the 2 stars, while they orbit each other, they continue to stir the gas and dust, causing those astrometrical shapes of the gas that you can see. And on this website, it says, as the star ejects shells of material, dust and molecules from within them, changing the landscape, even as the star continues to expel material. So it is expelling material. You can see jets of stuff coming out of it, and light going through the gas clouds and everything. The dust will eventually enrich the areas around it, expanding into what's known as the interstellar medium. So I think we mentioned that last episode. And since it's very long-lived, the dust may end up traveling through space for billions of years and becoming incorporated into a new star or planet. So it's kind of like a recycling system. A star dies, emits all its stuff, and then it can be incorporated into something else. Yeah, I just love to stare at this one. It was one of the ones that stood out to me as well.
This is some sci-fi level stuff, this image, isn't it? Yeah.
It's amazing.
But it's not sci-fi, it's sci-real.
It's real. It's real.
It's
That's
the real
the
deal.
best thing about it. It is the real deal.
It exists. Yeah. Or it existed.
It existed.
Yeah.
Yeah, who knows?
Who knows?
I
Yeah.
mean, it may be fainter now,
Yeah.
but it's just to capture this moment,
Mm.
you know, of
Yep.
the star's life cycle.
Yep.
It's pretty amazing.
Yeah. Now, off to the left, there's a
Yes.
galaxy as well in the background. Like they've.
There is.
Yep.
There is.
Just
so
another galaxy thrown in there.
That's right. And you
Yep.
probably remember the scientist speaking about this one on the presentation when they
Yep.
were presenting the pictures. He was like, I
Yeah.
wasn't sure what
They
it
took
was.
bets,
And yeah. And they're like, I didn't think it was a galaxy, but the others were right. It actually turns out to be a galaxy on its side. I mean, how
Wow.
big is this?
Yes.
This thing is
I mean, you
huge.
know, it's just,
Yeah.
So they captured a galaxy. There you go. James Webb Space Telescope going ahead and just capturing galaxies in the picture again. So
Yeah. This is just
I
showing
mean,
off now. Showing off.
just showing off.
But please continue showing
Amazing.
off, James Webb.
Yeah.
Yeah.
Oh my gosh. I seriously can't wait to
Yeah.
see more. Let's go through the last one. So
Mhm.
the last one is actually a graph, and it is a spectrograph showing the gas giant WASP 966 atmospheric composition. So they pointed to this exoplanet that they knew about. Let me tell you, WASP 96b is one of more than 5,000 confirmed exoplanets in the Milky Way. It's located roughly 1,150 light years away in the southern sky constellation Phoenix. It represents a type of gas giant that has no direct analogue in our solar systems, nothing like it. So with a mass of less than half that of Jupiter and a diameter 1.2 times greater, WASP, so it's kind of puffy is how they describe it. So it's puffy. WASP 96b is much puffier than any planet orbiting our sun, and with a temperature greater than 1,000 Fahrenheit, it is significantly
that's hot.
hotter.
Yep.
Yes. It orbits extremely close to its sun-like star, just 1/9 the distance between Mercury and the sun,
That's right,
completing
yes.
one circuit
Yep.
every 3.5 Earth days. So as we know, our Jupiter should be a hot Jupiter, but for some reason it's out there.
It's in the wrong place. Yeah.
It's
Ah.
So we can have a whole discussion about that. But
Yes.
anyway,
That is a fascinating topic, by the way. Our
it is
Jupiter,
a,
yes.
it's an extremely fascinating topic.
Yeah.
So WASP 96b was observed for 6.4 hours as it moved across its star. So they call it, I think it's called direct imaging. They put a coronagraph on top of its star so they can kind of block the light out and see the planet and observe the planet. And they pointed the spectrograph at it. So a light curve was then created and a transmission spectrum was revealed, and it measured the amount of water vapor in the atmosphere. It also it was able to measure the temperature of the atmosphere. So when they looked at this spectrograph, the spectrum came up with water. It had a distinct signature of water, and it's something they didn't know would happen. And there's evidence for clouds and haze. So it's a big puffy water steamy planet, it seems like.
Sounds like a little bit of a sauna, almost.
Yeah. So
Welcome to Galactic Hot Springs.
Galactic Hot Springs.
It'll
it's
melt your
just
face.
amazing.
Yeah, wow.
Yeah.
So that's just they threw in an exoplanet in amongst these the images, just to show off what it can do, and they were able to get this. They were able to find that water was predominant in the atmosphere of this exoplanet.
Yeah. So now the hope is, isn't it, Caroline, that they will be able to do this with multiple planets and possibly eventually find one that would be capable of sustaining life or human life.
That's always the aim, isn't it, for scientists to find a planet that is kind of similar to Earth, and then we wonder, is there anybody living on there, or could we move over there, or something like that?
Yeah.
So
send a little gift package or something. Just hey, galactic
so
neighbors.
they've got send a bunch of flowers.
Yeah.
Roses.
Nice.
What they've got is they've actually got a whole program set out of what is going to be observed, and there's a lot going to be observed. So yes, there'll be many exoplanets. They'll be pointing to things in our solar system. They'll be pointing to galaxies. They'll be pointing. There's a whole lot of stuff, a whole lot of science that's going to come out of this. And this is just a tiny, tiny sample.
This is the beginning. Yeah.
It's the beginning, but it's a good representation of what the telescope can do.
Yeah.
And there was one more image, Lindsay, while it was testing.
So just to flex its muscles for us, James Webb did another one. Now, this is just a test image, so it's not a completely clear one, but it's just to show us what it will be able to do. Is they produced a photo or an image of Jupiter that they took as kind of like a test to see how everything works with one of its moons. I forgot which moon it was.
I think it was
but
Europa.
It's there anyway.
Yeah.
It might be Europa. Okay, cool. Yeah. So again, it's just a test image, but the thing is, they will be able to have a clear, looking image of Jupiter. Probably
isn't that amazing?
in a lot of high detail.
Gosh.
Yeah,
you don't need to send a probe out there for photos anymore.
You can you just got James Webb to aim it. Yeah. I wonder. I'm thinking. So Carolyn, it was New Horizons that went to Pluto. I wonder if James Webb now would just cancel out what New Horizons did and give us even better images of Pluto now.
Well. The planet. This is one of the thoughts I had because it's one of our favorite projects, right?
Yes,
we love the Kuiper Belt and we're keen to see what else is out there.
Yes, yeah.
And the first thought I had was, I wonder if it's going to be pointed out to the Kuiper Belt, and they will be doing that. And I wonder if we're going to get, some information about what is out there. So they would be able to collaborate with New Horizons because New Horizons right there and continually measuring and all of that. So it's just another tool, an amazing tool to add to get more information about what's out there.
I just feel like poor Horizon's been doing all this work and all of a sudden his big brother would go, hey, there we go.
Fancy.
Hey there, small fry. Here you got some images of Pluto. Check this out.
That's not a camera. Right. This is a camera.
Yeah, you call that a camera? Yeah.
Poor Horizon. But look, it's great to see that Horizon's still doing work. It's doing what it needs to be done. It's cool. Awesome.
Well, New Horizons stunned us with the images of Pluto. That was, again, that was another mind-blowing.
It's still a planet. I'm sorry.
Yeah.
Planet.
Still a planet. We're going with that. Yeah. Sorry, International Astronomical Union. You got it wrong. You botched it. You got it wrong there.
You botched it. Yeah.
Might be tiny, but it is a planet.
It's still a planet.
Yeah. Fantastic.
So,
all right.
There we go. We'd love to hear thoughts.
Yes.
Comments. Anything about what we've spoken about
Were you
today.
as blown away as we were? What discoveries have you heard about from these images?
What do you want to see?
And please post in the Let's Science Discord if you like any later on any other discoveries that come out, because I'm sure it's going to be too much to keep a track of. So if there's a discovery that James Webb makes,
it's a good place to share.
If it's something that blew you away or was really exciting, please throw it in so we can all share the excitement with you as well, because we love it.
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest.